All attendees are in listen-only mode.
Hello everyone, and welcome to the webinar. This is Sydney speaking, and today's webinar will be doing again SolidCAM 2014, but part 3. And we'll be showing basically everything that, all the stuff that we really need to know about the SolidCAM 2014. And basically what we're showing you, what we've done here in 2014, it just made the program a lot easier to use and a lot more user-friendly, and also to work a lot quicker in many cases. Of course, at the end of the session, there's room for any kind of questions that you may have. And if you do have questions, all you have to do is click on the raise hand button. And after you click on the raise hand button, in the question area, write down your question. And don't forget, when you finish writing down the question, click on the send button so that I can see the questions at the end. And then I will answer all the questions at the end of the webinar. Okay, so let's get started. Now, the first thing I'd like to actually show you on the part itself, actually not necessarily on this part, but the first thing I'd like to show you before we even get into the actual different areas of the webinar itself, is something about our SolidCAM settings. And it has to do with tools. So if I were to go into SolidCAM settings and we go into, as I said, SolidCAM settings, and we go into our spin and feed defaults, we've added now the option of being able to have a default for our tools and feeds and speed for feeds, specifically when using the feed link in, lead in and lead out, and the link between passes as well. You can set this as a default value now over here, instead of programming it every single time in a different tool. Now, once you do it over here, every single time you create a tool, you'll have these values that you have in here. For example, I'll make my feed lead in at 50%. I'll leave the rest exactly the way it is, and I'll click on OK. What that does is as follows. When I go into creating a tool, let's go into my regular tool table over here, and I'll create a new tool, say an end mill. If I go into my tool data, you'll note that the values that I had over here for my feed link and my feed lead in and my feed lead out were automatically put into my tool data for this particular tool according to the values that I had over there. As you noted, I had changed it to 50%, so it came in now at 50% as shown over here. Okay, now one more thing inside the settings, which actually will get me into my first leg of the webinar, has to do with HSR and HSM. If I were to go into my settings, excuse me, and we have the option of updated stock. Now, in updated stock, we have two options. It always worked with the way it worked. We didn't even have this option before, but we've added a specific option specially for HSR and HSM. What this actually does is when you have operations that are all the operations are HSR and HSM, it'll actually make the calculation go a lot quicker. And I'll demonstrate this to you in a few moments. It actually deals with the updating of the stock itself. And again, this is in the case where all of the operations are HSR and HSM. Well, instead of me talking about it over here in the air, let me actually show it to you on the part itself. What I'm going to do is very simple. I'm going to take the part that you see in here, and I'm going to add an operation. Now, before I add the operation, I want you to take a look at my settings over here. Now, this option is available on a part settings level as well. So just because you had your default settings one way doesn't mean that in a particular part you can't have it a different way. Okay, so if we go into my settings over here, we have our, updated stock calculation. We have the option of regular and special for HSM. I'm going to leave it right now in regular and do a calculation of a new operation first using the regular updated stock calculation, and then we'll do the exact same thing using the other settings and we'll compare the two. Okay, so if I have this first operation over here, let me just go into it. I'm not going to do actually anything over here. Everything is really set over here. All I'm going to do is, this is just a roughing operation, and I'll do save and copy because I want to get all the values that I had from the previous operation to this operation. And then I'll say, let's just do now a rest roughing operation. We have a tool, and I'll choose a bullnose tool. I'll select that. And in my passes, I'll have my step down go every 2 millimeters. Now, that's all I'm going to do. And now I'm going to click on Save and Calculate. And let's see how long the calculation actually takes. I'll start now. Okay, and I'll count down as we go. You'll note, as it's going down over here, it's starting first to calculate the updated stock. Now, when it finishes doing the calculation of the updated stock, only then will actually start calculating the tool pass that it has to go. Right now we're into 15 seconds of the calculation and it's still doing this part. We'll let it go. Right now it's at 20 seconds and it's specifically waiting until this finishes. 25 seconds. Okay, now it's starting to actually calculate the tool paths. 30 seconds. And we're now on 35 seconds. And I'm going down even further. You see the calculation is going on over here as well. We are at about 50 seconds now, correct? And we are at 55 seconds. And we're going up even further than that. We're going up, we're hitting the 1 minute mark now. And it's still calculating, which is okay. It's a calculation that we have. By the way, even in the regular HSM calculation, they do go a lot quicker than they used to. But even so, specifically when you have large parts, the calculation can still take time. Okay, we're about the end of the calculation now, and we are at 1 minute and 25. There you go, 1 minute, 25 seconds. Okay, I'm going to write that down, 1 minute and 25 seconds. And now I'm going to exit the operation. I'm going to delete what I did at this particular time, this particular operation. And I'm going to go back into my settings. Now, in my settings, I'm going to go back and change this time my updated stock calculation to special for HSR and HSM. Now we'll just repeat exactly what I did before. Go into my operation, save and calculate exactly what I did before, nothing different. Change my HM roughing to rest roughing. Choose a tool, and I'll choose, as I did before, the same bullnose tool. I'm going to go into my passes, change my step down to every 2 millimeters, and now I'm going to hit on calculate now. Note, it goes directly into calculating a tool pass. All of these updated stock issues are automatically taken care of in here. Now, this works when you have all of the operations before this hand, they were all HSR or HSM operations. Okay, we're up to about 20 seconds now. And you see how quickly now we're moving along. 25 seconds. We are up to 30 seconds now. Remember, before we had 1 minute and 25 seconds. Now we're at 35 seconds. And we're coming up to 40 seconds. And we're at 40 seconds. 45 seconds. Okay. So we compare 1 minute and 25 seconds to 45 seconds. That's approximately anywhere between 35 to 40% savings in time in calculation of this particular part. Now, this part, right now, all I did was one operation. Imagine having a part that had 15, 20, 25 different operations. We're talking about a lot of time over there. We're not talking about a minute or two. we could be talking about an hour, 2 or 3 even, of savings as far as just the calculation time itself, depending how fine of a step down you're doing. All of this, you save time now by using this type of an operation. Let me actually, this type of settings. Let me actually close this part and now load one more part to work on, also using the same options. And the part that I'm going to load now is this part over here. This is a relatively heavy part. And again, I'm going to do the exact same thing. Okay? The part is being loaded. This is a much larger part. And again, let me go into my settings. We will have my updated stock calculation. I have it set at regular. And we'll go into the operation over here. Save and copy. This operation, I'm going to have this as a rest roughing. Again, choose a tool. This time I'll be using a bullnose tool, a smaller bull nose tool. And in my passes, I'll set this down at 2 millimeters. Now I'm going to start my calculation exactly now. Okay? Again, you see it's doing the calculation of the updated stock first. And we are at 5 seconds. We're going down to 10 seconds now. And it's still doing the calculation of the updated stock. And now it's only for starting, again, the calculation of the tool pass itself. As it's going down now, we are now at 25 seconds. And we just hit 30 seconds. As you see, it's going to go on. It'll be almost about the same amount of time. Now, again, I'm only doing this on one operation, and I have pretty big steps that I've actually taken over here. Again, imagine if this had many HSR, HSM operations, and you had to calculate them all. It would take you a long time to calculate. It can, like I said, it can take you sometimes hours to calculate. Saving 40% time on that will give you a large savings on the part itself. Okay, this one took us 1 minute and 5 seconds. Okay, I'm going to close this part. Close the operation. Again, delete what I did over here and go back into my settings. Go back to updated stock calculation, and this time use special for HSR, HSM. Start again a new operation by doing save and copy, changing it to rest rough. My tools, change my tool to a 12 millimeter bullnose tool, and in my passes, I'm going to change this to 2 millimeters. I'm going to click on Save and Calculate now. And as you see, it already did the calculation of the updated stock in this area over here immediately. And it's already it's working on the actual tool pass. Now again, this is helpful. This works when you have operations that are all HSR, HSM. If you have an operation that's beforehand a drilling operation or a face mill operation or pocket operations, those will actually, then you do not use these because it does not, this particular case does not update the stock. Okay, we are almost done over here and we are at 40 seconds in this particular case. Okay, so you can see, imagine the amount of time you would save when you have many operations, just not one operation, but several different operations. Okay. Okay, by the way, if you have any questions, please write it down in English so I can understand it. Okay, now let me close the operation, this part itself. And I'm going to start a new operation, a new part. Okay, the part is closing and we will start a new, open up another part. Okay, the next part I'm going to open up is a part that looks like this. And what I'm going to be showing you in this part is some of the new options that we have inside face milling, as well as some new operations that we have inside Toolbox. Now, if we take a look at this part, I'd like to do a face mill operation on the very top of the part from the entire stock. And then after that, I'd like to mill out this long slot over here. Then these semi-closed slots over here. And then work on these ramped areas over here, sitting on a cylinder as shown over here. Okay, so for my first operation, I'm going to use a face mill on top over here. 2.5D face mill operation. Excellent, no problem. The geometry, I'll use that from my stock itself. And you can see we have our geometry over there. And then I'll go down to my tool, select the tool. I'll select the face mill, which can cover this in one pass over the top. No problem over there. I'll change from hatch to one pass. Now, what we've done here is as follows. Normally, if I were to work on one pass, it will go down the middle of the part in one pass to the very end. Now, people have wanted in the past that instead of going down straight through the middle, they want to have a little bit of an offset, not directly in the middle of the part itself, but slightly offset from the middle itself. So what we've done is as follows. We've added another option inside one pass called Shift from Center. Say I were to shift it by 5%. Let's do save and calculate and run my simulation. What you'll see is as follows. The tool will go down, but note, as it goes across the part, you can see that the tool pass is not in the middle, but shifted to the side by 5%. It still covered the entire part, but this time it was slightly shifted as to not, so that it did not go down the exact middle of the part. So now you have a little bit of control exactly if you want it on the exact middle or just off the middle itself. Okay. Now, let's continue with face mill itself, and I'm going to change the tool and say I don't have a tool that covers the entire part. In fact, what I'll do is I'll use this 16mm end mill that I have over here. Okay? When I use a 16mm end mill, obviously, in my technology, I'm not going to use one pass. Let's use the option of contour, where contour acts, sorry, here we go, contour. Whereas as contour actually, as shown over here, will actually go around the part itself. Now, in the contour, we have the option of link. In link, we have an option that we've added now inside ramping. Before, it would just go straight down into the part. But now we've added the option of vertical ramping. Now, with vertical ramping, if I go into my data now, I can actually tell it where I want it to actually approach into the part itself. Just like your regular pocket operation. So if I want, I can go and click on that over there, and it'll actually start working. It'll actually enter the part from that point over there. Let's just take a look at our simulation over here now, and you'll see that the tool goes straight down and then went down the middle. Then it went out and started working on the outside of the part. But I had control of exactly where I want the tool to go down. Okay, now let's start our next operation. And then what I'd like to do over here is first, before I even start working on these slots that I mentioned before, I have this very thin wall. Now, we all know the problem with working on thin walls is as follows. when working on a thin wall, if you machine everything on one side and then go over to the next side, once you don't have support on the other side, you are likely to actually bend the wall because it gets to be very, very thin. So the way to work on this properly is actually to step in slowly on each side, always making sure you have enough support around that wall at all times. And as you're going down, you slowly machine away each side until you get to the very bottom, always making sure you have enough support on the wall. Now, for that, we've actually created in our toolbox an operation specifically made for thin walls. And you guessed it correctly, it's called thin wall machining. Now, in thin wall machining, it does exactly what I wanted to do. It works in steps going down in the part, but you'll see exactly how it works because we have actually two ways it works. One for rough cutting and one for finish. Now, first let's pick our geometry, and our geometry as shown over here are the two top lines of the thin wall itself. So I'll choose my geometry. I'll choose this line first, except that the order that I pick it in and direction that I pick it in does not make a difference. So we have here now, as shown, we have our two line geometries over there. Excellent. Now, the tool that I'm going to use is going to be that 16 millimeter end mill. And my levels, just a reminder as far as my levels go, I do not have to click on upper level and then pick the top surface or the depth button and then pick the top. I can actually just highlight this area over here and click directly on the surface. By the way, if I don't want to see the tool, just get rid of it. You'll note that this field has been populated automatically just by clicking on that surface. If I go over here, highlight this area, just click on the surface itself, and that will get that surface height as well, that level as well. Okay, now let's go into our technology field. Now, in our technology field, we have two ways of working: alternating steps and supporting steps. Alternating steps works from side to side as it works its way down the part. This is used for rough cutting. So what I'll do is over here, I'll do a wall offset of 0.3 millimeters, leaving that for the finish. And then we have our step down. Let's step down every 5 millimeters on the part. And then we have our offset for our clear offset. Now, if we take a look in the part itself, what I need to do is actually work from the outside in on both sides. So if we have clear offset, I can just simply click on this and put in a value. Just click on that line over there, and that value will automatically be populated over here. Of course, that's the actual total value from there to there. Let's just change this to where I want it to be a little further in. Let's say 28 millimeters. Okay. We have our extension, how much I actually want to go past the part as I'm cutting past it. Let's just leave it now exactly the way it is. We'll run save and calculate, run my simulation, and I'll use my simulation of HostCAD, but but showing the stock as well as I'm doing it, and we'll see it from the side view as shown over here. Okay, as you can see, we have our stock, and our tool goes down and clears away the part. It took its first step. Now it goes over to the other side. Note it goes on alternate sides, always making sure you have the even amount of material on either side of the part itself as it goes in. And the first step, it'll go all the way in up until 0.3 millimeters before the actual finish of the wall. And notice at this point, there's a small amount sticking up. Okay, that's not a problem. Now, my next step, however, I don't want to go all the way in to the wall itself, because now I'm starting to create a thinner wall that's even longer, and I'm going to have less support over there. So let's see what happens now. It'll do this step, as shown over here. Keep on going all the way through to the part itself, up until the step that I wanted to go to, up until this point over here. Now note, it got to this point over here. Now it's going to the next level. And it's going to keep on going further and further out, always making sure that there's enough support area on the outside of that wall itself. Let me actually run this now a little quicker, and you see it does this all the way down on the part until it gets to the very bottom. Now when it gets to the bottom, and I'll stop it at this point, you'll note now it's starting to work on these points, and now we'll go back to one step at a time. Again, it's doing one step at a time, constantly making sure there's support over here. And it goes down always to the very bottom, and then it'll go another further step down, as shown over here. Always making sure that there's enough room on the part itself until it reaches the very bottom, as shown over here. Okay? One step over here, and the same thing over here. Now, let me zoom in over here, and you can see we have our 0.3 millimeters left on each side. So now I'm going to exit this operation, and I'm going to do one more thin wall operation by doing save and copy for the finish. I'll use the exact same tool, and in my technology, first of all, I'll put my wall offset at 0, and this time I'm going to change it from alternating steps to supporting steps. Okay. Now, the supporting steps we're going down every 5 millimeters. Let me do save and calculate, simulate, and I'm going to zoom in to the wall itself over here and start cutting. Note, its first step, it's not going down the full 5 millimeters. Instead, it's going halfway. Okay? Did the halfway step, cleared it off. Now it's only going to go down to 5 millimeters on the opposite side. As you see, it's down at 5 millimeters. And when it's cutting, you'll see that this part over here has been machined away already, but it still has that little support on this side over here as it's cutting. Finishes that side, now it'll go down to its 5 millimeters from this point over here. So this was 2.5, now this is 7.5. Leaving again this side being machined over here, 5 millimeters, but giving the support that it still needs on the other side. And it works all the way down to the very bottom, always making sure that the support on the thin walls. This guarantees that your thin wall at the end will not bend. This is the actual proper way for working on thin walls. Okay, now let's go to my next operation. And next I'd like to show this slot over here. Now, the operation I'm going to be showing you now, the next two operations for this slot and these semi-close slots, are specifically designed for working with an end mill that actually works with inserts, not actual whole end mills itself, but actually an end mill that has inserts, such as ISCAR inserts in it itself. So we'll start a new operation of toolbox cycles, and let's first start with this straight open slot. So for that, we're going to use the option of roll into open slot. Now, what's important when machining with insert end mills or any inserts is to try and roll into the material itself rather than go directly directly face forward into the material itself, as to avoid that sudden shock of hitting the material itself. Okay, so we'll choose our geometry. The geometry in this particular case will be this line over here, and then this line over there. That's it. The tool, I'm going to use that tool that I used before, the 16 millimeter end mill. And again, my levels, my upper level will be here, and my depth will be up until that surface over there. In my technology, what we have is as follows. We have approach distance and step down. Okay? Now, looking at this step down, this step over here, we have its 10 millimeter step. So you know what? I'm going to, sorry, my upper level, this was over here, sorry. in my technology field, I'm going to have my step down at 10 millimeters. I'm going to do it all in one step down. Now, we have something here called approach distance. Now, we're going to be rolling in to the material itself, but we have an approach distance so as to approach this point over here from the outside from a specific distance. Let's put this at 2 millimeters so we can actually see it a lot better as it rolls in. Now, what's going to happen here is as follows. This is automatically going to make one pass down the middle of that particular slot. Let's do save and calculate, and we'll show our simulation. Now let's take a look at the simulation from our top view and look in this area over here. And I won't do the solid verify view, just the regular wireframe with the tool. And note, the tool will go down. You note it's a distance away from that outside wall. Now it moves in that 2 millimeters, curls in, has that roll-in movement as shown over here, and then goes across the part until the very end. Okay, again, you can see that as it happened on the part. Okay, now I still do want to finish this particular wall. So for that, I'm going to do a different operation. By the way, we will be adding in here a finish option within this operation right now. But for now, to finish this, what I'm going to do is very simple. I'm just going to leave that. Let me just go back to save and copy. And this time, instead of roll into open slot, I'm just going to use the regular simple slot over here. Same geometry, same tool, levels, the exact same thing. And my technology, I'm going to leave it exactly the way it is, leaving a wall offset of 0, as I'm going to finish up those walls itself. Now, the result will be as follows. As it gets to the end, as shown over here, it won't go up in the air to its safety distance and going across, go back down. It'll go directly across to the next wall and then come back without having to go up. Run my calculation and simulation on this. You'll see that the tool goes down. Let me just flip this around over here to this side over here. And you'll see as it comes across, it'll go directly to that wall without going up in the air and then going back across over there. Okay, now what I'd like to do is another operation. Excuse me. I'd like to do an operation for these slots over here. Okay, 2.5D, toolbox cycle. This time I'll be using the option of roll into close slot. And this will also not only roll into the slot, but it'll also finish the wall as well. Now, it should be noted that again, I'm using this is specifically meant for tools that have inserts. Okay, not the solid carbide tools, but the regular insert tools. Okay, we'll create our geometry. I'll use this as my first geometry over here. I'll accept that. Note, I don't have to close or anything like that. And you know what? I'll do the other side as well. And that's my second chain over there. Accept that. Choose my tool. Again, I'll choose my 16 millimeter end mill. My levels, upper level is here. Depth is up until that surface over there. And in my technology, again, we have our step down. Let me just put it at 10 millimeters so we can have this do it at one step. And again, we have our approach distance just like we had in our previous operation when we had a regular roll-in slot, as we did before. So I'm going to have this work with a roll-in, again, of 2 millimeters. Now, what's going to happen in this particular case is that it's going to roll in not only in the middle, but in the end as well. Okay? Now we can also have a wall offset as it goes and do a finish. Let's just leave it exactly the way it is right now. Take a look at my simulation, taking a look at it from the top view, and we'll see exactly what happens over here. We have the tool again rolling in the middle. Now went up, and now it's going back and rolling on the wall itself. The same thing on this side. Let me do it again slowly, one step at a time. The middle. Now it's going on the wall. It rolled in on the wall itself, work its way around, and now it goes to the other side as well. Doing the exact same thing on the other side. Okay. Next, I'd like to work on these areas over here. On these sloped areas that are sitting on a cylinder as shown over here. This is actually a half cylinder over here, but this entire slope is on the cylinder, as well as the one on the other side. So I'm going to use another toolbox cycle operation. This time I'm going to use the option of an angled cylinder as shown over here. My geometry in this particular case, I'm just going to choose this line over here. The rule is that you choose the first line over here, the top line over here, and then the actual arc itself as shown over here. I'm just going to do that one. Just do this one for now. My tool, I'm going to use that same tool I used before. And note when I go to my levels, my depth is automatically given to me by the geometry itself. Okay? All I'm going to choose my upper level, in this particular case over there. My depth, I'm not going to even touch that. I'm just going to, because that's done with the geometry itself. And in my technology, we have the following. We have a maximum step down, or working with the scallop if we want to. We'll keep our maximum step down over there. We have our step over, how much you want to step over each time. Now, the whole idea behind this operation is that as it's working on this surface over here, at the bottom of the surface, at this edge of the surface, the outside of it, it does not need long passes because there's not that much material over here. But as it gets closer towards this line, it needs longer steps. So only use the longer steps where it's necessary, and in these areas, it'll use shorter steps. Let's take a look at the actual calculate. But you know what? Wait a second. Before I do calculate, the part has to be done also on the second side. Well, since this part is exactly sitting exactly in the middle and exactly on the other side in this particular case, I'm just going to do a simple transformation in this particular case, and I'm going to rotate it around the middle. Let's just give it a little bit of a rotate of 180 degrees. Include the original, rotated one time, as I said, 180 degrees. Add that, and you can see that's all I had to do over there. Click on OK. Now let's do my save and calculate and run my simulation. You'll note as follows. The tool is going across on the part itself. Now, let me actually run this quickly towards the end. Take a look from the top view. You'll note that this area has shorter length tool passes, whereas the ones closer to here are actually longer, making sure it's always covering the entire surface itself. Now what you're seeing here obviously is the center of that particular tool. Now this was done as well on the other side because of the transform that I did over there. As we look to the side of the part, you'll see that it has that step down on the part over here, making sure that's going along the way of this particular surface over here. Okay, next. I'm going to actually open up now a turning operation. Okay, let's go into SolidCAM Open. And we'll go into turning this particular part over here. And what I like to show in this particular part is that we've added a new turning operation. It's called iMachining Turning. And it's very similar to the actual iMachining that we have inside our milling operation. What it does is it basically does a trochoidal movement on slots as shown over there, and also finishes off the corners as well, but always making sure that it does not over engage the tool. Okay, but you have control of the actual engagement angle of the tool. Let's see exactly what's going to happen. Let's first start on this area over here. Now I've created an operation, and if I were to open up that operation, and we'll take a look at it, you'll note it's called iMachining Turning Operation. The actual geometry in this particular case is this area over here. This is the actual geometry over here. Now the tool when using this operation must be a tool that has a ball end as shown over here. Next, we have our levels, but let's go into our technology. That's the important part. We go into the technology, you'll note we have the following: minimum cutting angle and maximum cutting angle. In other words, you have complete control of the minimum and maximum cutting angles on the part itself, and also you can work on this one way or zigzag. Let's do it one way for now. Now let's run our calculation and simulate the part itself. Let's actually run the solid verify inside the host CAD to show the simulation. What you'll see is as follows. You'll note that's actually working on that surface. Let me start again from the beginning, a little bit slower this time. You'll see that it's actually working on the part in a trochoidal manner on the part itself. You can actually see the toolpath in trochoidal, and you can see that the engagement angle is being kept between the areas that we needed to be kept over there, exactly the way I wanted it. And it's working exactly on the part. So you can also work a lot better with the tool itself. It's better on the tool, and you can also work quicker this way as well. Let's just go to the very end, and you'll see that it machines out this entire area. Now let me stop over here. That's enough for now. And let me actually do this on another area. Let's do this now in an area, but note this area is different. It's not a complete arc like we had before, but we have actually here even sharp corners. Let's see how this is dealt with in the operation. Again, my geometry in this particular case is this area over here. This showing us up into where we have actual stock, so it's going actually all the way to the stock itself over there. A tool, again, the exact same tool that we had before with the ball end as shown over here. And again, in our technology, we have the same option of minimum angle and maximum angle. This time I work zigzag. Let's run my simulation in this particular operation now. And I'll do this one step at a time. Now just updating its stock from the previous operations, since I didn't run it yet. And we'll see the following will happen. Note it works exactly like it did on the other slot itself, going back and forth. Now let me run this through the entire part. But you'll note over here, when it gets towards the very bottom over here, you'll see what will happen. Let me finish this off. As you can see the angle that's being created over there. As it's getting close to these walls over there, it'll go further and further down into the part itself. Okay? And as it gets to the bottom, we'll see this in a moment. You'll note what will happen in the corners itself. You'll see, by the way, what these movements are actual trochoidal movements inside turning. Now look what happens in this point over here. It's working on the corners, but making sure never over engaging the tool in the corners itself, just like the way it works in iMachining. The same thing will be done on these corners, on this corner over here, on the flip side. It'll actually do the exact same type of movement. Okay, as you see, it's doing the exact same thing over there. Okay, now let me open another operation in turning, another part in turning. Excuse me. Let me see. Here we go. Open. Yep, we use that part, this part over here, sorry. And now this is just a quick show of a little bit of a change we've made in the way the actual tool works. In our previous versions, when we had, for example, working on the internal of this part, actually this is true for every part now also as well. If you use lead in your links, when you had lead in and lead out, if you did not use a lead out, or those you kept it at none, it would in any case move a safety distance away from that wall, from its endpoint, and then go out of work away from the part itself. Go away from the part itself. Now, what we've done is as follows. If you choose in technology, in your link, you keep this at none, it will not move that safety distance away. And what this will actually do is protect your part. In other words, you have complete control now of how it moves inside. If you don't want it to move inside away from the part, no problem at all. It'll have that little movement away, but it won't move away that safety distance like it did before. Let's actually run the simulation, and I'll use the turning option for looking at the simulation, and I'll zoom into this area. My geometry is up until this area over here, and note this area was already machined out. So as the tool goes in, no problems going back and forth on the part itself, doing all its rough cutting. Now, as it finishes its rough cutting, now it's going to do its last pass on the rough, going on this entire wall over there. Now, the geometry is up until there, but it also in the geometry we extended it towards the stock going down, and I'll show that to you in a moment. You note that it goes down. As it goes out over here, that's it. It'll go out directly. Notice it will not move down the safety distance. Had it moved down the safety distance, you ran the risk of this touching this area over there. Now that won't happen. It'll go directly out of the part since you picked none. Okay, I'll just demonstrate how none looked, even though it works correctly over here. First of all, let me take a look at geometry like I mentioned before. The geometry itself, looking from the side view, is actually just this area over here, but we also did a modified geometry, having it extend down towards the stock over there. Okay, now the way it worked previously is, and I'll demonstrate this over here in my link. It worked as if I had this value length of 2 millimeters. This would be, I'm just doing it as if the had a safety distance. This will work just like the safety distance. Now tangent. Let's see exactly what happens. And this is the way. This is actually what happened previous versions. This is why we stopped using that safety lead in and the safety distance and the lead out. If I go over here now, again, it'll work exactly the way it's supposed to. But now when it does its finished cut, as shown over here, when it did its safety distance going out of the part, as it's going to do now, note the holder actually went into the material, and that's not good. So that's why we dealt away with the, if we have none over there, we do not use the safety distance. Okay, one last part. We're going to load this part over here. And what we'll see in this part is as follows. You'll note that we have drilling operations that have to be done over here, as well as around over there. And this area over here, I'm actually going to machine out using iMachining, 3D iMachining to machine it out. However, I'd like to do a drilling operation inside this area over here up until that surface. Okay, so for these, I'd like to use a regular 2D drilling operation. But for this one over here, I'd like to use a 3D drilling operation so that it recognizes the stock, making the target itself, making sure that it won't go into the target itself. So if I go into my 2.5D drilling operation, what we've done now is we've combined our 2D drill and 3D drill all into one operation. Instead of having it two separate operations, we have it now as one. And this will actually help us navigate between the two operations a lot easier. We'll start off with the 2.5D operation, 2D drill operation. Our geometry in this particular case, we just click on this surface, picking those 4 holes over there. We'll choose my spot drill. In this particular case, I use my 16mm spot drill. My levels, my upper level will be over here. My depth will be to that same surface over there, but using a diameter value of my depth to go up until that diameter over there. As shown, it's going to go up until 12mm diameter. Run my simulation. Let's take a look at it from the side view, and you'll see that the tool will go down. I'll do this one step at a time. Get rid of that, and you'll see it go down exactly to where it has to go down to, and then go back up. 12mm diameter of the tool went down to the 0 level, and it machined out. It drilled out exactly the spot drill that I needed over there. No problem at all. And my next operation, I'll just do save and copy. Again, this time I'll just change my tool to a 12mm drill. My levels, my depth this time of the tool will go down to this point over there. It's shown as grabbed over there, and I'll have the full diameter go down over there. Of course, we have our technology, what kind of cycle I want to use. Let's just leave it exactly the way it is right now. And as you see in my simulation, I'll use Solid Verify for the simulation. The tool goes down and machines out all the holes. Now, next, I'd like to use this same drill inside a 3D operation for inside over there. So I'll just do save and copy. And I'll change this from 2D to 3D drill. Now, you know, I did not have to leave my 2D drill operation to go to the 3D drill operation. And I can use the same, the same tool that I had before. Note my target is put in here automatically. My geometry in this particular case, I'd like to have it at the center of this. So I'll just choose the option of pick position. And for my tree over here, I'll just use my chord system Mac 1, which is sitting exactly in the middle in this particular case. If I didn't have that there, then I'd just turn it to the side and have it go over there. Okay, and I'm just going to do save and calculate and exit. Forgot to show you over here as well. In my levels, you'll note my lower level is set at -85. That's the entire part. However, since it recognizes the model in my geometry, as I showed you over here, it recognizes the target. It knows not to gouge into the part itself, even though my levels over here shows at -85. Let's run the simulation of this, and you'll see in Solid Verify that the tool goes all the way into the part itself, but only until the depth that it needs to go in over there. And of course, it did not go through to the bottom. Now, why did I do a drill operation over there? Because I'm going to do now a 3D iMachining operation, iMachining 3D. And since I have a whole drill over there that's larger than the tool I'm going to be using, the tool will plunge into the part itself right into the hole instead of doing a helical motion into the material itself. Again, 3D surfacing now, iMachining operation. The tool in this particular case will be a 10mm end mill. And I'm not gonna do anything over here, just gonna leave everything that the way it is. Leave my technology wizard exactly the way it is. Let's just run a quick calculation, and we'll let the calculation finish on this itself. Now, while it's calculating, I see there's one question over here. Does thin wall milling only work with open contours? Yes, it does. Right now, it works only with open contours, as I showed you, not with closed ones. And there's a question: could I create a 3D drill operation through 4 holes? The answer is yes. But the for regular drilling of regular drill holes over there, I would not necessarily do it for a very simple reason, because it's based on the target. Now, if if you're using your same diameter drill as what the hole is, it may see the drill actually touching that surface, as it's a 0, 0. For one surface there, there's actually no tolerance between the two. It's actually 0, 0. So it actually may not go through. You may have to bluff a little and maybe have your drill be smaller than the hole. Then you can use it. But when using your regular drilling operation, I would not recommend this. What you can do, however, is use your regular drill recognition operation for that. But let's continue now with the actual operation that I did over here. Let's run my simulation using Solid Verify, and what you'll see is as follows. The tool will go down into the hole itself and then work its way around the part itself. So we used the 3D hole in this particular case, but look, you notice how easy it was for me to actually go from one operation to the next, from a 2D drill operation to a 3D drill operation, without me having to leave the option of 2D and then opening up a new operation in 3D. Okay, that's basically it. One note, and this is particularly to a question that I had answered last week. There was a question that somebody asked me last week about chamfer recognition, whether it works on only on horizontal flat floors itself. I answered no, it worked on angle floors too, but that was a mistake of mine. I did not exactly understand the question. The answer, I was looking over the recording I did before, and I saw that I did not answer that correctly. When you're doing a chamfer recognition operation, it recognizes flat floors that are exactly perpendicular to your Z. Okay? If it's in an angle, it would not go on the edge of an angle, as well as the edge of the top angle of that as well. Okay? It only works on the flat floors. So that's a correction to a question that was answered to me last week. Okay, I'd like to thank everyone for joining me in the webinar, and everyone should have a great weekend, and see you in our next webinar. And of course, this webinar has been recorded, so you will be able to see it sometime tomorrow online as well. Take care and have a great weekend.